Okay, let's try improving our bullets. It's always a good idea to experiment with different speeds and timings for gameplay elements. These bullets could definitely do with a speed increase. So let's edit our gun script, and we're going to go find the bullet function, which tells the bullets to shoot out, which is down here. And it tells the bullet X velocity and Y velocity. And it also sets the rotation. So let's try increasing here. Our velocity is, there's a bit of trigonometry here, but this is the number we need to worry about, 800. Let's try increasing this to 2000. Both of those numbers there for the X and Y velocity, 2000. And let's give that a test. So those faster bullets, they look a lot more impactful. Let's see, let's just make them slow again, see what they look like. It's a bullet. Could try 500, see how that looks. And then if we go and make that 5,000, that might be a bit too much. I'd say probably 2,000 or something around that is a good number. It'd be cool if our bullets weren't laser beam accurate. So we might go and change the accuracy on our bullets as well in the gun script. Reducing the predictability of game elements can make things seem less uniform and more organic, which is naturally more pleasing to experience, just like the real world. Randomized bullet trajectories will help with that. So let's go and find, in our gun script, we want to go and find our shoot one bullet right here. Down here, when we're shooting the big bullets, we could randomize our rotations. So this one is shooting to the right and this one is shooting to the left. Instead of just saying rotation is 360 and rotation is 180, let's give a little bit of a range so we can randomize these rotations. So we go to operators, grab random integer, and we'll start up here. The rotation was 360 degrees. Let's try from 355 to 365. So about a 10-degree variation in the way that the bullets will shoot. And this one was supposed to be 180, so let's randomize that 10 degrees as well. So 5 degrees minus 180 is 175. 5 degrees plus 180 is 185. Let's see how these randomized rotations for the bullets look now. So that looks pretty cool. You might want to tweak those numbers until you find something that feels right down in here in the shoot one bullet function. Maybe less, maybe more, up to you. How about some impact effects? We know that special effects can draw our attention to action in the game, so we'll add some sparks showering off surfaces when the bullets hit them. So our bullets hit walls or zombies, we'll get some sparks coming off them. We have an effect for that over here. If we edit our sparks script. Okay, so when our sparks are created, we want to disable the physics and add a sparks tag on them so that the gun and the bullet can go and identify them. So we'll go to physics and grab set physics enabled false so the sparks won't collide with anything. And then from sensing, we want add tag on myself. We'll tag it as sparks. And then when the level starts, this one particular spark will make go invisible. So from events, when the level starts, And then from looks, set visibility to false. And then the sparks have a little animation that they play, and that's their idle animation. And when they go and do their spark showering animation, when that's looped, we want the sparks to destroy themselves so they don't just keep playing that animation over and over. So we'll go to animation, and we'll grab this block here. When animation idle has completed, let's change completed to looped. So as soon as it loops once, we will check if it exists, and if it's visible, it should destroy itself. So we'll go to control flow and grab an if block, and then duplicate that if block, put another one in there. Now the first thing we'll check is, do I exist? And that's from sensing, up the top there, myself exists, if myself exists. And this is handy just to make sure that it's not trying to play an animation or check if an animation is looped, if it's already been destroyed. That'll give us an error, so that will prevent that. We also want to check if it's visible. So if we go to looks, we'll grab get visibility of myself. And then from control flow, destroy myself. Okay, so that'll make the sparks work. Let's close that now and save that. Now we need the sparks to get triggered to appear. Let's edit our bullet script over here. And we want our bullet to make those, to tell the gun to make the sparks appear. So the bullet's going to say, hey gun, put some sparks near me when I collide with something. And colliding is down here for the bullet. When I am touched, get toucher. If the bullet is not touched by another bullet, it'll destroy itself. Before it destroys itself, let's get it to spawn some sparks. So we'll go to control flow and grab an if block and put it above destroy myself. And with this if block, we're going to check, was the bullet touching on the left or the right or the bottom? And we'll get sparks to appear on those three places. So we'll change this if to an if, else if, else if. So 3 conditions to check. Let's go to physics, and we want to check first, was I touching on the top? So we'll grab this block, touching on any side. We'll start with touching on left, and then duplicate that, touching on right, and duplicate that, and touching on bottom. So left, right, and bottom will create sparks. And if the bullet was touching on the left, we'll say sparks left, and we'll tell that to the gun. So we'll use a message block from events. Down under message sending, we want this. Send message to object with myself. Drag that out, send message, and the message will be sparks left to an object, and the object will be the gun. So click on object, change that to gun, and myself is good. It'll tell the gun, hey, here's where I am. Let's duplicate that, and if I'm touching on the right, we'll send a message sparks right, and if I'm touching on the bottom, we'll send message sparks bottom. Make sure that's spelled correctly. Okay, good. Now let's go and edit our gun script. So our bullet is saying sparks left, sparks right, and sparks bottom, telling that to the gun. Edit that gun script. Now the gun needs to keep track of the sparks. So in the same way that we set up a class for muzzle flash, we're going to duplicate that set class muzzle flash block up here when the level starts. We'll make a new class. So we'll click on that duplicate muzzle flash and select new variable, and let's call this sparks, and it will be a class, and it'll be the class of the first instance by tag sparks. Okay, so it's remembering some sparks. Then let's go all the way down to the bottom, and let's set up some message receivers. So we had sparks left, sparks right, and sparks bottom. So we'll go to events, and we want this block. When I receive message with a value. when I receive message with a value. The first one was sparks left. And when I receive sparks left, I want to create a new instance of the sparks. So go to draw and grab create new instance of class, and let's call that sparks. And then this value that is being received was the particular bullet. So we'll save the bullet as a variable as well. We'll save it as a local variable. So we'll go to global and local, scroll down a bit, create a local variable. Actually, we've already got a local variable here we can use, bullet instance. Let's drag that out. Bullet instance, and let's set it to that value. So we'll right click on value and then click create get value. So the bullet is being kept track of, the sparks have just been made. Now we want to set the scale and the position of the sparks. So if we want sparks to appear on the left, we're going to set the scale to negative. So we'll go to transform, set X scale of myself, get rid of the myself, and we want this instance here, these new sparks. So we'll right click on that and create get instance. The X scale of the instance will be -1, and the positioning of them, that's from transform, set X position and set Y position, but not of myself, it'll be for that instance. And it's going to go to the position of the bullet. So the instance, the sparks, will go to the position of the bullet. So from transform, we want X position of myself, get rid of myself, and we want to go to global and local, and grab local instance, bullet instance. So the sparks will go to the position of the bullet, and then we also need that for the Y position as well. Okay, now we also had sparks right and sparks bottom. So let's duplicate sparks left and change this one to sparks right. And we only need to change one thing in here, or a couple of things probably actually. The scale needs to go to 1 to be positive. And the X position of the instance sparks needs to go to, let's try position of bullet plus 20. Let's try that. Plus 20. Cool. And then let's do the duplicate that again and make this for sparks bottom. And we want to this time rotate the sparks instead of setting the scale. So we'll delete that scale, we'll go to transform and grab set rotation of myself, get rid of myself. We want to rotate that instance, the sparks, and let's rotate them by 90 degrees so that they will be facing up. Cool. And then let's, instead of setting the X and Y position, let's try setting the center X and center Y position. Might be a bit easier to get it positioned nicely. Set center X and set center Y. And then from transform, we'll grab center X and center Y. And we want the center X of the instance, the sparks, to go to the center X of the bullet. Alright, and then the same thing for the center Y. Center Y of the instance goes to the center Y of the bullet. Okay, sparks left, right, and bottom. Let's play the game and see if these sparks appear. And that actually looks pretty good. Okay, nice. Now let's get the hit animation on the zombie working. It's nice to know if you hit the zombie. Did I hit that zombie? Then it should react to that. That's where that character animation comes in. We'll add a damaged animation to the zombie. Alright, so let's edit that zombie script. And let's find our get hurt function, which is right here. We're playing our sound effect in there. Let's also play an animation. So go to animation and grab play animation. And let's play the hurt animation. Now, one thing we've got to remember now that we're playing animations outside of our play correct animations function is if we go up and have a look at our play correct animations function, this is constantly running. So if we say play in an animation down here, get hurt, we don't want it to instantly be overridden by these other animations. So these animations should only play if hurt is not playing. So we can add an if block around all of this to check, wait, is hurt playing? Okay, if hurt's playing, don't play these other ones. So we'll go to control flow and grab an if block, put it in play correct animations, and then we'll go to operators, grab an equals, and from animation we want current animation, and we want to make sure current animation is not hurt. So we can change that equals to a not equals. It's the equals with a line. And then we can just grab a text block from one of our animation blocks there. And this one is hurt. If current animation is not hurt, then we can go and play our other animations. Okay, let's see if when we get hurt, when the zombie gets hurt, will it play its hurt animation? Okay, it is playing the hurt animation, but it keeps looping that hurt animation. So we can fix that by adding a block. Let's go down to the bottom here and we'll add a block from animation when animation idle has completed. Let's change that to looped, and the name of the animation is hurt. So when the hurt animation has looped, we'll get it to go and play its idle animation. Okay, from control flow, we'll grab an if block and we'll just double check, does the zombie exist? That's from sensing up the top, if myself exists, and then inside there we'll put another if block, if health is greater than 0. So operators will grab an equals, we'll change that to greater than, and then from variables we want number health. If my health is greater than 0, I can just grab a 0, and if I do have more than 0 health, then I'll go and play my idle animation. That's from animation, play animation, idle. Okay, good. We'll just double check that that worked. Okay, that looks great. Now how about some knockback on the enemies? We want to keep making player actions have more impact on the game world. Bullets shouldn't just absorb into enemies and allow them to keep running. They should be forcefully thrown back. So let's go edit that zombie script again. We'll make them get thrown back when they're hit by a bullet. Okay, let's go and find our get hurt function again down here. Now in our get hurt function, we will make the zombie jump up a little bit, and then we'll check if I was touching on the right side when I was hurt, I'll move to the left, I'll get thrown back, and if I was touching on the left side, I'll get thrown to the right. Okay, so we'll go to physics and grab set velocity X. And let's pop that in here under removing some health. Okay, and let's first throw them up. So velocity Y. Let's kind of randomize it a bit. If we go to operators, grab a random integer from 1 to 100, and we'll throw them up between 200, negative 200 and negative 400 Y velocity. So they don't all get thrown up perfectly the same amount. It'll randomize a little bit. And then we can do the velocity X. Let's try a random number between 500 and 800. Now remember, we need to check if they're hit on the left or on the right. So we'll go to control flow, grab an if block, and change this to if else if. And then from physics, we'll ask under collisions, touching on any side, if, and then change that any to touching on left side. If I was touching on the left, I'll get thrown to the right. And if I was touching on the right, I'll get thrown to the left. Remember, left is negative. Okay, let's see how the zombies get knocked back. Looks a bit better, doesn't it? Whoa. Okay, pretty cool.